class, welcome back. We're now in week 7 and into lesson 7.1, and we're continuing on with the biomimetic design process, and in 7.1 we're talking about the abstract phase. Alright, here we are back with our challenge to biology design spiral. You did the identify phase where you're identifying the functions you want a design to perform, and then you practice interpreting or translating those from the design world so that a biologist could understand what functions you're trying to perform, which sets you up so that you can go discover how does nature perform those functions. Now that you've done the discover phase, you say, okay, now I've discovered some strategies in nature for doing the functions that I've identified. Now you're going to reverse the process that you did here and translate it so that an engineer, another designer, a manufacturer would understand the function that you're trying to describe. So you're going to abstract out the function that you discovered in nature. And it, of course, looks like this in the whole sequence. And the idea, again, is that we are dealing with these as individual steps. And when you get better and better at this, they'll blend more and more together. However, it's always important to deal with them as individual steps because, as we talked about, each phase has its ability to be divergent, and then you converge again, and divergent, convergent. If you go too fast and blend too quickly, or go to that temptation of jumping right to the design phase, you'll miss the huge expansive power of creativity. And again, when you're a sustainable designer, what you're really aiming for is radical innovation, and you need to go through and really be in each of these steps in order to get all of that power out of it. So in the abstract phase, you've discovered a function in nature. It's really cool. And now you're going to have to figure out how those strategies actually work. All right, and that will require identifying the underlying principles behind that function. So essentially what you're doing in the abstract phase is reverse engineering the strategy. I know you're probably not an engineer, maybe a couple of you are, but the idea of reverse engineering is you take a finished product and you say, I get what it does, now how does it do it? And you take it apart, you try and figure out how does it do what it does. And that's exactly what you're going to be doing with whatever you discovered, whether it's an organism or a system in nature. You're going to reverse engineer the organism for that particular function so you can figure out how that strategy works. You know you're successful at the end of the abstract phase when you're able to describe the strategies using only technical terms. And if you remember back in this phase, we said you know you're successful in the interpret or translate phase if a biologist understands what you're talking about. In the abstract phase, you know you're successful if an engineer who has nothing to do with biology or biomimicry or nature understands what you're talking about. And they go, okay, I could work with that. So when you're in the abstract phase, put your back to nature and be talking to the world of design, of engineering. Now, when you discover lots of different strategies for performing functions in nature, as you did last week, we talked about looking for patterns. Okay, now in the abstract phase, you're really going to examine those patterns to see what's emerging. When you have a whole lot of them, you start to see the pattern, then the underlying principles start to reveal themselves, okay? And one way to help you do that is to create a taxonomy of your strategies. So whatever the strategies you find, organize them in some way. You'll find clusters of things. Okay, these guys are all doing it in this way. These guys are all doing it in another way. And you'll start to see general principles, approaches, patterns. And each organism will do it differently, but you'll start to see patterns emerge. And organize those things, and that will be really helpful in the abstract phase, because remember, the abstract phase is leading you into the emulate phase. You're setting yourself up, or perhaps another designer or engineer, when you're doing the abstract phase. Okay, strategies, what to look for. It's the same thing we told you in Discover, that start looking for materials, forms, shapes, geometry, etc. But in the abstract phase, you are really diving down to saying, okay, I understand that it is a material. Now, what exactly is that material? What properties does that material have that allow this organism to perform that function using that material? Okay, is It might be that material has to do with form or shape or chemistry, or it might be the form that the whole thing takes, the shape it takes, the geometry that's applied. It might be a process, so something dynamic, or it might be a chemistry, some part of the metabolism of the organism, or part of a system in the outside world. And again, in the abstract phase, you go beyond identifying that it is a form or a process or a system, and to figure out what is that process, what is that chemistry. And it can be, again, it could be synergies. It could be that the organism doesn't perform that function at all, that it sets itself up, its strategy is it sets itself up to have someone else perform that function, or the function is performed by the system. And so in the abstract phase, you dive deeper and figure out exactly what these things are. Things to consider when you're abstract phase, again, it's similar to what we talked about in the discover phase, but instead of just knowing that it's about it, you want to know what it is. So look for scale. Is a strategy happening at the nanoscale? Is it at the organismal scale? Or is it at the landscape scale, perhaps? It could be at a hierarchy of scales. The answer to all those questions is yes. It's a combination, a unique combination of say, geometry at the nanoscale, the organismal scale, and the landscape scale. Again, you figure out if it's based on dynamics, what are those dynamics? Does it change over time as the organism grows, as it moves? Is it dependent on movement to perform that function? And as we said before, almost always nature works in terms of combinations. It might be a combination of material, surface structure, and a process. Okay, so you may not be looking for one thing. You might be looking for a combination of things. And again, we're looking for patterns, and that's going to be really helpful when you get to the emulate stage, because you determine these things for one specific organism strategy. We start to see, okay, this and that and the other combinations and strategies. Then you can start to use those if you find the pattern in when you come to the emulate stage. So looking for those patterns is really important. And it will also help when you're abstracting, when you find a strategy, what other functions is it performing? So it might be you see it's got this certain structure, for example, and yeah, that creates color, but why would it bother to go to all that trouble just to create color? Oh, it's because it's also waterproof. That particular strategy actually performs multiple functions. That's what we talked about earlier about optimizing across the system. It can be the various systems within one organism. And also, when you see this one function, it might be taking multiple strategies in order to perform that function, which is similar to the combinations in order to perform that function. All right? So when you explore all these things and consider these things, it'll help you to actually get through the abstract phase. So for those of you more graphic, the discover phase is when you say, oh, I discovered this morpho butterfly in Costa Rica creates this gorgeous, vibrant color that's even more vibrant and colorful under direct sunlight. Well, that's the problem that we have with our technical stuff. Our screens, the one you're looking at right now, for example, laptop or a cell phone screen, they work horrible under direct light. I mean, have you tried to use your laptop outside? Maybe you're one of the lucky ones that have one of those newer screens that's based on biomimetics. But when I take my laptop outside, the bright sunlight makes it impossible to see. So a company discovered how the morpho butterfly creates this vibrant color under direct sunlight, figured out how it did it. It was based on the structural color and some kind of a layering. It abstracted that so that it could emulate it in its technology. Now, if you were to do this properly, and not to say that you're doing improperly, but you're doing this for class purposes, but if you were doing this like for an industry, you'd have abstract phase can be quite technical. So you're going to need a lot of technical expertise to do this. Perhaps, maybe not. So for example, in this case, the morpho butterfly creates its color at the nano scale. And so it does it to test it. They use all kinds of different wavelengths and different angles to see exactly how is it playing with these different light, these different wavelengths, and then creating the vivid color that we see. And then it looked at it from a structural standpoint. What are the different structures? What are the relationships among the structures? What are the distances between them? What do those there's all of those microstructures within the bigger structures? We've got this hierarchy of scale, and within that, what's the length, the geometry and the materials that all go together. So that can be abstract and can be quite serious science. You won't need to do that for this class, of course, but you do need to understand that is what goes on. Okay, after this video, you're going to watch, read a chapter out of this book, Invention and Evolution, Design in Nature and Engineering by Michael French. One thing that's really great about these sorts of books is that if you're not an engineer and you don't really get engineering principles, some of these books that span biology or nature and engineering are really nice entry point for non-engineers to start understanding engineering and understanding how engineers think, which is really helpful when you're in the abstract phase. Okay, so you go from the world of biology to, okay, here's how it might be engineered. Okay, so people that are good at spanning these two things will help you with your abstract phase. Then you're going to do your BCI site, and I'm going to have you reverse engineer an organism. Even if you don't know what that means, the idea is while you're sitting there contemplating one of the organisms that you've discovered, you're going to try and imagine how does it perform whatever function that you've been observing. And then you're going to do an exercise where you get to practice abstracting strategies for your biomimetic design process. And as is going to become your habit now, you're going to write a project update report just for the abstract phase, okay? And if you, so this will help you build towards your final portfolio project. Okay, that's all I want to talk about with the abstract phase, and we will see you in the next video when we talk about Emulate.